Hello, and welcome to this webinar on Oracle Machine Learning. And we're going to do a fun one today, guys. We're going to do how to pick a good wine for under $30 using Oracle Autonomous Database, Oracle Machine Learning, and the Oracle Analytics Cloud. And I have with me two colleagues, Devani Sheth and Sudesh Eugenie, both excellent machine learning and many other kind of things here at Oracle. And we've been having some fun. We're going to walk you through how to solve a problem, and it's a fun problem. We're going to try and find a good bottle of wine. So the story on this one goes, we've all been there. We get invited to a party. We need to bring something. We think we're going to bring a bottle of wine, but there's so many choices, and we want to be frugal. We don't want to spend too much money for our wine. So we want to see if we can use machine learning to look at a lot of wine reviews and wine ratings done by like Wine Spectator and people like that. And we want to use that machine learning model that we're going to build to apply it to other wine options that are in the bargain bin, let's say, in the store or maybe on the expensive shelves. And we want to see if we can pick out a good wine, but not spend too much money, okay? So that's what we're going to do. And if you need to reach out to us, you can see all of our contact information here. Feel free to do this. And we've also put all these demo assets out in the GitHub, in the Analytics and Data Oracle User Community GitHub. So we'll show you where that is at the end, and you can use those things. So let's get on with the show. So the product that we're using is called Oracle Machine Learning. It is part of the Autonomous Database. So this is free if you have, and in fact, the Autonomous Database is free these days. So if you have an Oracle always free tier Autonomous Database and you want to pick out a good wine, you can download this notebook and off you go. But Oracle Machine Learning has been part of the database for quite some time. It's been a priced option. It's gone by other names like Oracle Advanced Analytics, Oracle Data Mining, Oracle R Enterprise, things like that. It's all called Oracle Machine Learning now. And we have different sort of sub-names like Oracle Machine Learning for SQL, which are the core native, in database implementations of the 30-something algorithms. That's mostly what we're dealing with here. We're going to access those algorithms via a notebook session. That's called Oracle Machine Learning Notebooks, and that comes with the Autonomous Database. It's the SQL algorithms also come inside of every database, as do the Oracle Machine Learning for R is in all on-prem and database as a cloud service. Oracle Data Miner, you see over on the right, is part of SQL Developer, so on-prem and database as a cloud service environments, you can use that. Oracle Machine Learning Python, Oracle Machine Learning Auto, ML, user interface, and Oracle Machine Learning Services are things that are coming out later this calendar year as we deliver this webinar in mid-October 2020. And then we also have Oracle Machine Learning for Spark, which is a library of algorithms that run outside of the database. So there's a lot here, but basically what Oracle Machine Learning does is the core, most of what Oracle Machine Learning does is it extends the Oracle database. It enables users to build, AI applications and analytical dashboards. And because of these in-database algorithms, you can build applications. You do all sorts of amazing things. We're going to show you some of this. But we also have integration with open source Python, which is coming this calendar year on Autonomous Database first, and then also with R, which we've done for some time now on the on-prem and database to cloud service. So there's a lot of functionality here. And by Oracle strategy, I think unlike anybody else out there, Oracle strategy has been to not move the data to some other platform to do the analysis. Oracle strategy has been, hey, leave the data right where it is. Safe, secure, HIPAA compliant, scalable platform, security, auditing, backup, everything that you know and love, hopefully, about the Oracle database. Leave the data right there, and let's bring the algorithms to the data management platform and let the data scientists work in collaboration with the architects, the DBAs, and everyone else. So what we've seen as we've done this is a general evolution from what I'll call an Oracle data professional into adding data science, machine learning skills to their toolkit. So there's been more this sort of evolution that we've seen. We're going to show you how easy and natural that is going forward. So you can really just build predictive applications. The use case we're going to do today is a fun one, okay? We're going to use some data that we got off of Kaggle. We're going to share a simple ADW, OML, and Oracle Analytics Cloud use case because Oracle Analytics Cloud now integrates with OML inside the database. And we're going to build some notebooks. Devani's going to take us away on that in a few minutes. We're going to define a business problem. We're going to explore the data, identify the key attributes. Once we've built our good model, we're going to leave the results in the model where? in the autonomous database, right? Because that's where we're going to come back in and make our predictions, leave our predictions there. Sudesh is going to come in and show you how we can use Oracle Analytics Cloud to kind of sift through all that, maybe score some more models, do whatever, and try to get us a good bottle of wine for cheap. So the functionality that we're going to use could be any of these. We're mostly using here, I think what Tavani is using is, we've been using random forests over here, random forests, and also support vector machines. We could have used any of the classification techniques pretty much, because the way we've defined this problem is a good model, a good bottle of wine and a bad bottle of wine, or not so good, greater than 90 points, less than 90 points. So we're into the area of classification, but we could have used other algorithms to solve other kind of problems. What's interesting, I think at least, we think on this one, is that the data that we're using is not just standard structured data. We have wine reviews. So you'll see the reviews. They say, oh, this wine has a very robust flavor. I smell the aroma of cherries, and on and on and on. We're using Oracle text under the hood to take all that unstructured data. What's stored in the database is a CLOB, character large object. And we're going to walk through, Devani's going to show you how we kind of also do that. It's a very natural kind of thing. In the notebooks, we have to do a little bit more setup with a little bit of code. In the GUIs and in the AutoML user interface that's coming, we'll put sort of bumper pads on that, so you just have to click. And in fact, the new notebooks will actually generate the code, so you can go back and, as a citizen data scientist, you can get your good bottle of wine, but then hand off that notebook to another data scientist who can take it further, perhaps. So we can do structured data, unstructured data, spatial data, graph relationship kind of data. The algorithms are inside the database, and they're sort of pure functionality with everything else in the database. So the models we're going to create are first-class objects, and this just opens up a lot of doors. One, for ease of building and deploying applications, and two, just speed. So with Oracle machine learning, we're trying to, at Oracle, manage your data as we always have been for many, many years, but now more and more analyze your data while it's there. And you see the stuff that's sort of on the left of this little gray line, the RStudio and the SQL Developer drag and drop. That's what people have been using for quite some time. As we go forward and go to the autonomous database over here, we're trying to set up a complete environment. We just go to a URL and off you go. And it's very straightforward. So under the hood, when we do these things, just for those who are kind of curious, what does the API look like at its core, at its lowest common denominator? The SQL OML for SQL API looks like this. I'm not going to show the R or the Python ones because it's a different session that we'd cover those. But here we're going down to the core native SQL ones, which the other ones talk to, but so under the hood, they all kind of do this under the hood. But we're going to do a DBMS data mining create model. Wine class model is the name of the model. We're doing classification. There's the data set, there's the ID, there's the target field points bin. And then once we've built the model, we're going to apply the model, and you'll see all that. So we're going to dive into the thing in a second here. What we're going to do is, what we started to do with Devani and Sudesh and I had done was start out using some of the example notebooks. And there are 9 example notebooks that we ship with the product, and we're going to use as a starting point one of the classification models. So we look at the examples, open them up. You can't run them because you're just they're sort of for read only. So you download them, and then you open up in your environment, and then you can just edit them. And we did a little bit of editing, and we're going to take it over now to Devani, who's going to walk us through this. So I'm going to stop sharing, Devani, and pass it over to you. I can figure out how to stop sharing here. Let's go back here. Okay, back to here and stop sharing. Okay, over to you, Devani.
Thank you, Charlie. Okay. Oh.
There you are. And there it is. Yeah. We can see everything. It looks good.
Okay, so this is what is our Oracle Machine Learning notebook, Apache Zeppelin. It comes with your autonomous data warehouse. So what you have to do is you have your data in your ADW, and then you can start using Oracle Machine Learning notebooks to investigate that data and run machine learning models with it. So as Charlie was mentioning, today we are going to pick good wines which are less than $30. And we're also going to, in accordance with all of the data, we are going to do Oracle text mining as well. So first, let's explore the data that we have. So we have for each row that we have an ID. Then which country that wine belongs to is description. Then the designation, the points, that is where our focus lies. So what is the points, the price as well, and the province that comes from, the regions, what's the taste, and the name of the person who reviewed this. So this is what we have. And since we're going to do text mining, we're converting this description column into a CLOB object. But before we do that, first we populate, we have a points column, and we're going to do a classification problem so that we come to know whether a wine is good or bad. And we're going to do it as greater than 90 points and less than 90 points. So we divide the table, we put all of the wines with respect to whether they have points greater than 90 or with a tag greater than 90 points, and similarly less than 90 is less than 90 points. That's what we are doing here. And then we have the table. Then we divide the table into train and test data first, so that we can run or we can build our model on our training data, and then we can test our model on our testing data. And now we convert our varchar to CLOB so that we can use Oracle text mining. So we are basically adding a new column and then setting the previous description column to a new one and then dropping the column. And this is what we have then for our columns here. And this is again what we have for our test data that we did. So you can see that description is now CLOB. So now that we have basically explored or seen and made our table ready, let's do some data understanding as to how is it distributed in our table. So here we can see that how many reviews or how many wines in our data set do we have which are greater than 90 points and then less than 90 points. So you can see that the lighter shade of blue are all less than 90 points. And if you hover over that, it gives you the actual point and then the total number of data that you have with respect to. So say here, we have about 96 records with 89 points. And then we have 123 records, which have 90 points and so on.
Hey, Devani, can I just make a comment here? So
yeah.
When Oracle Machine Learning Notebooks does this, by default, it's going to do just a simple visualization. So we actually have 130,000 different lines that are in here. But by default, for the Zeppelin graphing, it's going to say, well, let me just take the top 1,000. So it's sometimes in the notebooks, we're going to show like we push the computation down into the database and we return the accurate results. Here, we're just taking Oracle Machine Learning Zeppelin notebooks are just taking the top 1,000. That's why the numbers don't quite match up. I just want to make that clarification. Thanks. Continue, please.
Thank you, Charlie. So going down, exploring some more of our data. So we have different countries as to where this wine belongs to. So some of the other distribution of our wine data based on the top 10 countries. And so we have US leading, and then France, Italy, Spain. And till now we have seen like bar graphs. Apache Zeppelin notebooks allows you 6 different types of graphs to visualize. So here we have pie charts as to comparing wines from different countries. So here we have all of the regions of Australia. And then here we are seeing what is the distribution in our data based on those areas in Australia. And we can compare it with, we have here US and then Spain. So you can mix, match, and you can use different visualizations in Apache Zeppelin. So we have table, we saw a bar graph, we saw pie chart, and then we have area as well as line and scatter chart as well. Okay. So now that we have seen our data, we have understood, let's get started into actually now building the model. So but before we do that, since we are doing this as a classification problem, and we already created our classification column, which is greater than 90 points and less than 90 points. So we don't actually need the points column as of for this. So we are removing that, and then we're basing our actual table on that. And as we mentioned before, as we saw before, we have the description column here, and we want to be able to use the reviews that are here in this description uh, to be considered in our machine learning model. So in order to do that, we are going to use Oracle text. So with this, you can do mining of unstructured data, and you can apply data mining techniques to text terms, which are also called as text features or tokens. And these text terms can be a group of words or words that have been extracted from text documents, and they're assigned numeric weights. So we're going to look how we can use Oracle text mining to do that. So first, we need to create a preference. So what we're doing here is we're creating a Lexer preference over here for our Oracle text mining. And what this does is you specify the name of the preference that you need to create. And then you give what type of Lexer preference that you want. And you can choose from basic Lexer and other types that Oracle has. And here we are giving it as a text preference. So because we're doing text mining, so we're setting attributes as to index text and index themes. And then we create another preference for our basic word list as to, we also need, since our description is in English, so we specify the language as English. And then we are giving setting some more attributes as to what will be the number of results that you want, and then the score. And then when we create the policy over here for specifying for doing text mining, you would basically give in the preference that you created for your Lexer and this wordless preference that you created. So once you have done that, then we come down to building models. First, we'll be seeing the attribute importance model. So here we are building. So you give the algo name. We're using a minimum descriptor length for doing the attribute importance. And then you specify the text policy name that you created before. And then the maximum features that you want your model to use. And just one second. Yep, and the default is 3000. So this will basically tell you the maximum number of features to use from the document set. And once you run this, on the right-hand side, we can see that now we have our attribute importance, and we have ranked it based on the ascending order of the rank. So we have price, then province, variety, and then now you can see that we have different specific words from the description that we have in our table, giving us or letting us know that they are basically more important, or rather they influence the points attribute in this case. So you can see terms such as palate, wine aromas, acidity, finish, the richness. These all are very important for a good wine.
Hey, Devani, can I just throw in a couple of comments here?
Yeah.
So first thing is, notice the amount of time it took to run this, right? 54 seconds on 130,000 records doing text mining. That's pretty cool. The second thing is, for those of you who have been comfortably using the Oracle Data Miner drag and drop, user interface that's part of SQL Developer, there's a column filter node, which is basically what Devani's doing over on the right-hand side. And you may see something here you haven't seen before, which is unstructured data is being shown as the actual words, the tokens, palette, wines, aromas, and the coefficients are how strong each individual word is. In the GUI, we didn't switch that on because, at least I don't usually run it that way. I don't think that generally works. But here, because we're going at the API level, we're exposing a little bit more capabilities here. So I just want to toss that in there. Sorry, Devani.
Yeah, thank you, Charlie. Yeah, so now we have, as we've seen, built the attribute importance model. We can go ahead and build our classification model using both our structured data and the unstructured data. So as we built our attribute importance model, in a similar way, we are going to build our classification model. So we are using support vector machines over here. And once we are done with that, let's evaluate the model over here. So this is how we score and evaluate a model. We apply the model that we just created to the test data, and the results are stored in our wine_apply_result. And to see how good or bad the model is, we're going to do a lift. So we compute a lift chart, and we build a lift chart over here to see how our model is performing against the random guess. And this is the result of the data mining model that we just created. So we have the target value, uh, the attribute name, and we have the coefficient and the reversed coefficient in this case. Now let's see, now let's evaluate or apply the model to a specific data points. So on the left-hand side, what we see here is we're exploring what all the wines that are predicted to be good wines. So we did a classification greater than 90 points or less than 90 points. So for each row in our test table, we have what it was predicted to be. And this is what we see over here. And on the right-hand side, what we have done is, so we are only focusing on the wines that have been predicted to be good wines. And then you're comparing it with the bad wines over here. And for us, the good is greater than 90 points in this case. So if we can see over here that we are applying our model result to our actual data set, in this case, the main data set, and then predicting it. And since we're applying the model, so we get a prediction as to what that wine falls into which category. And then its probability of being, in this case, greater than 90 points. And then we have also grabbed the actual description and the country over here, and some other parameters we have as well. So we can always see over here that our model is doing good, as the probability over here is, say, greater than 90 points. And then we can see the description also mentions all of the characteristics of a good wine. Moving further, some of the other things that you can explore with our Apache Zeppelin notebooks is, here we are showing 1,000 wines which are less than $15. As you know, we wanted some inexpensive wines in this case, and we need but a good one. So this is what we have done over here, and we can see in which countries all of these wines are coming from our data set. So based on our model, which predicted that all of these wines are less than $15 and greater than 90 points. So we can see that France has a good number of wines that are good as well as cheap. And then we have US as well. And then some wines from Italy and Chile as well. So moving on, now we'll see how we can investigate all of these our wine insights and predictions a bit more further using Oracle Analytics Cloud. And for doing that, we have done some preparations, and this is what we've built some basically what we did was we created some more tables so that they can be accessed to Oracle Analytics Cloud. And we ran our model on all of the entire data set. And we're creating this table so that we can use that for visualizing, getting us more insights using Oracle Analytics Cloud. So I'll hand it over to Siddesh now for giving us those insights.
I think actually I do the handoff. I do a little bit of stuff here.
Oh, okay.
So excellent, and we were being really frugal there with only $15. I think we're going to come back and end up spending a little bit more money to finish this off. But I'm going to pick up where we were with the PowerPoint. We're right here, and then we kind of dove into it. And these summary of what we did are in the handouts that we'll also post. I guess I'm going to do a blog post and I'll put it out there. We may also put the PowerPoints out in GitHub, but all the code that Devani just showed you and what Siddesh is going to show you in a minute is out in GitHub now, and we'll show you where that is, but we'll also put these PowerPoints for sort of posterity so you can kind of see what's going on here. So you see everything that she did here, see recoding, creating the target field, creating the 60-40 train and test holdout sample. She changed the data type to CLOB, character large object. We explored the data visually. We did more data visually. Now, something we hadn't updated those things. So this in the last, it times out on you after like 10 minutes or so. So you didn't see this, which is a little drop-down menu thing you can get with Zeppelin notebooks. So if I change that from US to Spain or whatever, it'll update the graphics sort of interactively. We have a little bit of that peppered in here. You see all the text mining, the attribute importance, the building the model, the results at the end, and model coefficients at the very end that we saw, the end results and more end results. And then now we have this table. So now that we have the table, wait, there's more. We're going to come back in and see if we can look at this data. And we have this wonderful integration between Oracle Analytics Cloud and Oracle Machine Learning. So we've got the notebook over here. We've got Analytics Cloud over here that can talk to the stuff in the notebook, right? You can talk to, in the database, you can talk to all those results. And so at this point, I'm going to hand it over to Siddesh, who's going to continue on and show us how to pick a good bottle of wine here. Take it away, Siddesh.
Sure. Thanks, Charlie. Let me share my screen. Okay. Can you see my screen?
Yes, we can.
All right. Okay. So before I go and show the different types of visualizations or the insights or the building of a story that we came across from the results that Dhwani showed. So one of the main things that I wanted to show here is the capability for Oracle Analytics Cloud, which is Oracle's BI platform, to be able to talk to the database and the results that we have on the database, right? So it's a pretty powerful feature that we have within the OAC itself, because now that once you run all those models and everything else that are run on the database, you can just directly use them and very quickly and very easily be able to get results. So in order to do that, all you have to do is, once you log into OAC, this is the home page. You just have to come here, register the ML model. If you don't have the connection created to your database already, you can create the connection. But in this case, I already have the connection created. So I'm just going to go into that. And you can see, right, this particular database that we've been doing the demos, there are multiple different types of models that we've built. We can use all of them that's lying on the database. So that, once the model is built and customized to satisfy your use case and needs, you can just use them and not have to like rebuild or run the model every single time. That's pretty much it's very useful in that sense. So in this case, you can see just now, this is the wine class model that we built. So I'm just going to choose that for now. So if I choose that, you can see all the different, the algorithm name is support vector machines. As Dhwani pointed out, it's a classification problem. So the different input columns, the output columns like prediction, probability, cost, details, and what are the hyperparameters, right? One, it's important to understand the hyperparameters for the model, especially with machine learning. So you can see all the hyperparameters that we've set on the database itself. So that's pretty powerful to have a model that's database in the database and be able to use that from a BI platform. So I've already gone ahead in interest of time. I've already chosen the model and built out some visualizations. So I just wanted to show you how easy it is to bring the models before I go and show the visualizations. So I'll just hit cancel and just go to the next tab. So let me just choose go out of this. I just want to make more space. Okay, so this is the one of the projects that I've built out for the wine classification problem that we're trying to solve here. So let's undo the filters first. So basically, first thing that one of the questions that we can have to answer is, where in the world will we get a wine? Excuse me. Where in the world will we get a wine that is less than $30 and it's pretty good, right? So the first thing that we do is get a geographic map and just map out based on the cost of the wines as well as which is a good wine. So first is the cost. So in this case, you can see the darker shade of the red represents a more costlier wine. And then the lighter shade may represent a much cheaper wine. So in this case, the most darkest wine is Romania. There's one in Switzerland. I think the France wines are pretty expensive. And we know that I think the wines in France are pretty good as well. So we can see that across the world, how the different wines are and how they are priced. So in that sense, similar to that, let's say I want to go for a wine in France, right? It's pretty expensive, but still, I just want to look at the different characteristics for those in France. So you can see for the country France, on the right hand side, you can see there are wines which are as cheap as $5. And then it goes all the way up to I think $76. So you can choose based on the prediction probability by running the model on the database. You can choose which ones you want to, and depending on your price and the amount, like your taste, so you can choose the wine appropriately. And then similarly, if I just these are the different so it's just a representation of this table in the graphical format. So if I just do this, you can see it will get updated just to show that particular thing. So if it's either way, it just shows you a different way to visualize the things. So let's just go back and let's just go back. Okay. Okay. So the next one would be, this looks pretty cool in my opinion, because you need to be able to categorize wines by variety as well as by price, right? By price and in specific regions. So for example, if I say in France and in US, right? I'm in US right now, so I just want to see which is the nearest best wines which are nearest to me. So I'm just going to say France and US for now. Let's see how that looks like. So on the one on the left is by variety. So you can see, I think Cabernet, Sauvignon, sparkling blend. There are different types of wines by variety, and these are the top 100 wines that we have by variety for in France and US. And the one on the right is by region or place of where we get the wines, right? So obviously Napa Valley is one of the major regions where we can get wine. There's one in Long Island, there's one in Oregon. So so you can see the closest ones to you. So say for example, I mean, for me, the closest one would be, I think, somewhere in New York or Long Island, but people in the West, they can go to Napa Valley, I guess, Oregon, etc. So in that sense, you can just drill it down and bring it down to where you can choose the best wine. Um, Next is a bit more in-depth visualizations. I'm just going to disable the filters just to show you how it looks. So in this case, the graph shows you the price by country, sorted by prediction probability. So you can see that the highest prediction probability is in England. I think there's some data and the reviews for the England one, but yeah, I think the one in Austria is pretty high and pretty good. So you can see
Well,
that.
Sudesh, can I just interchange here? I mean, interject here? Because
Yeah.
there's a story that goes with the English one. I got this from Francesco Tissot, who originally showed me this, something kind of similar. And he's from Italy. And he said, what is going on? Why? And it turns out all the English wines are reviewed by one person who happens to be from England. So it's very biased. So anyway, I just wanted to throw that part of the story in there. Back to you, Sudesh.
Okay. Yeah. Thanks, Charlie. So yeah, I think we see that Austria, I think we already saw it in the map as well, where somewhere in Austria, it's pretty good wine, like around $40. It's still expensive, but still it's pretty good wine. And the one on the right is also very important to understand, because sometimes graphs give you so much information as they can, but it's better to have a natural language representation. So OAC, or Oracle Analytics Cloud, provides you with a natural language representation of the graph on the left. So you can see that Romania and Switzerland are the highest priced wines. Different types of metrics that you can choose based on. So in this case, let me just search for a wine that I know. I think Chardonnay is one that I know of. So if I do that, it'll automatically drill it down for all Chardonnay wines across the world. So now it's just basically showing me all the Chardonnay wines where I can get the best Chardonnay wine. In US, I can get it for 68% good wine for $46. That's still expensive. I can, like in Portugal or in Greece, I think for if you want to go for a very good wine, and if you can spend a little more, you can go for that. So once we've chosen the particular country and the type of variety, so next we choose the different attributes. So this is also from the database. All this data is coming in from the database that Dwani showed, the OML notebooks. So we're just showing you the different attributes for a wine. So in a wine, what one looks at is probably like it's concentrated, or if it has aromas, acidity, wine. I mean, these are the different attributes that are highly important when we talk about the wines. And this is taking into consideration the descriptions of the wines. That was one of the columns in the data set. So we broke that down into words, and so that we can get specific descriptions. So you can see that the ones which are larger means they're more important versus those ones that are smaller. So it's basically doing an attribute importance. So once we do that, we classify both, as this is a classification problem. We classify both the good wines and the not so good wines. So you can see by the images that the one on the left is not so good, and the one on the right is more of a good wine. So all these are attributes showing that it's a not good wine on the left, and it's a pretty good wine on the right. So you can see, right? I mean, for all the wine drinkers out there, I think these resonate with you. So you might not like which is herbal, which is easygoing, various other attributes. And similarly with good wines, you can see that if it's concentrated, if it's impressive, delicious, beautiful, these are some of the attributes that or the characteristics that you look into while choosing a particular glass of wine. So once we do that, we saw, before I go into this, I just want to recap what I did. So we saw geographically where is the best wine, and how in terms of price and variety, which is the best wine. And then we saw different types of attributes. We picked up a variety called Chardonnay. What are the different attributes that make a wine a good wine versus a bad wine? And then now we are in the last stage where we're just going to choose a particular wine that we can buy for a party. So obviously we want a good wine. So in the price range would be, if you see, I've filtered out the data for the price between $11 to $30, and then all over the world. So you can see the different types of wines that are between the range of $10 to $30. So these are the varieties that are there. So if I say I want a Chardonnay, as I did for a variety, so you can see that a Chardonnay you will get for $24. Oh no, sorry. Give me 1 second while I do that. Let me just enlarge it so that it's easier. So if I do a Chardonnay, I mean, there's some issue with the data, but in general, you will see that you will get a Chardonnay for, let's just try that one more time. Okay, let's do this.
I think in the bars, it's hidden in between the labels there. You'd have to zoom in a little bit more maybe to see it. And one thing I was just going to comment as Sudesh is going through here, I think the dollars are not necessarily for a particular bottle. You see that on the right, on the left, you see the average price. So it's doing all those averages for you.
Yeah. Sorry, I forgot to mention that. Yeah, but it's averaged out price, right? I mean, if you pick a particular price range, on an average, what specific range that you get a particular bottle of wine is what is being shown. So we saw in the previous slide, previous canvas, we saw the different attributes here. So say, for example, I want one of the concentrated one is pretty important. So in that case, I want to see what are the different reviews or descriptions that say concentrated, right? Probably I will choose one, probably not. But in that sense, I'm using the data and the results that have come from the machine learning models to make an informed decision. So in that case, let me just find, I think there's one Pinot Gris somewhere which is concentrated, which is also pretty good, 65%, I think 65%, it's pretty good wine, and it's under our budget that we have. And similarly, there are I think close to around 200 wines that fit this particular.
Hey, so are you showing brushing there? Is that because you clicked on something else and those guys are lit up?
Oh yes, just because I clicked on this.
That's pretty cool.
Oh yeah. Okay. So once this is one of the cool features, I think, within OAC, that you can just click on this variety for Cabernet Sauvignon, and you can just basically, what you can do is just filter it and or highlight what you want to see. So in this case, you can see that there's a Cabernet Sauvignon for $16, which is pretty good, I guess. Concentrated, astringent mouthfeel. I mean, I'm not a wine drinker. Charlie, please feel free to.
Well, you're making me thirsty here, but this is pretty cool analysis.
Yeah. So we saw. I mean, before I wind up and hand it back to Charlie, I just want to recap. We saw in one particular project, we can see, like, I have drill it down from a high level where we saw the wines across the world, and bringing it down by price and variety, checking for the most important attributes, and then classifying them as good and bad wines based on attributes, and then making an informed decision on which wine or which type of wine to sort of buy for a party. And this can be applied to any use case. You can just apply it to any use case. The tool remains the same. It just, you need to just make some customizations. But yeah, the fact is, it gives you a head start by making use of the data and the machine learning models in the database, and be able to use that in the visualization and the analytics tool. So with that, I will hand it back to Charlie.
All right, very good. I will try to share. That was excellent, guys. I'm going to share some of my screen back here. So what I'm going to do is just kind of bat cleanup, guys. I'm going to show you. So this is what Sudesh just had shown, how we walked through this. And what's really beautiful, I mean, you don't have to go from OAC score the models. The models could have been scored in the autonomous database, but I think what OAC users like is be able to tap into the model that maybe Devani has built over in OML inside the autonomous database, and maybe it's an expense report fraud, model, or an automobile insurance claims, or different things. And you can just score, and apply it to your other set of data, and off you go. So just to summarize, Sudesh showed registering the model, picking a good model that we wanted to apply. I think what's really cool about this one also is we're doing all the text mining, right? You don't see that everywhere, and it's just, for us, it's just the data type is CLOB, and in the GUI we'll put more of a button on that, so you don't have to type out so much code. But you can take this notebook that Devani has all that text code in there, and you can just make it your own, apply it to your own stuff, copy and paste. That's the beauty of all this stuff. We've run it, leave the results inside the database, come back and look at this. Now I was going to point this out midstream, but that my favorite graph, the one of the 2 bottles of wine, the one that's thumbs down, the other one, that is looking at this DM dollar VL wine. Okay, that is how in Oracle machine learning you do what we used to call get model details, but we deprecated that feature. So now it's DM dollar VL. So it's kind of cryptic syntax. You got to look at each one. It's like DM dollar AI for attribute importance, DM dollar VL VX, whatever. It's kind of cryptic, but that is the syntax for querying the support vector machine model view. So the model is in the database with all those text tokens and coefficients. We query that. So that shows it up in the beautiful graphics, and that's how we do that. When we saw this, beautiful. You can drill through. So that showed all the cool. My favorite graph, absolutely beautiful. And there's the right here is the DM dollar. There's the DM dollar thing that I was talking about. And at the very end, we get a very good wine, whatever your flavor and taste is, or whatever you want to bring to the party and hand to others, whatever you want to do. And I've been on this kind of viewpoint lately. Maybe I watch too many Marvel movies, but it seems as if the converged database with all these analytics that are part of this database and built inside, and also this ecosystem around it, it does seem like it's the most powerful weapon for tackling data-driven problems. You have the database in the center, you have the Oracle machine learning deep inside of it, you got the analytics cloud that talks to it, the security and scalability of the database, OCI data science, another very complementary offering, and you get this whole ecosystem from Oracle that you can do a lot with. At the end of this, you keep on getting better and better at using all these Oracle in database capabilities, especially machine learning inside the database. And we haven't even tapped into the graph and spatial and network, all that kind of stuff as well that we could mine. We'll come back with that maybe as a future show. But hopefully you can evolve from being an Oracle data professional to an Oracle data scientist. There is some Oracle certification that we're working on towards this, so stay tuned for that. The assets that we've put out there in the analytics and data Oracle user community. So if you you can see kind of the URLs down here, analytics and data. That's actually got a newer one, andouc.org, and it'll take you to all these locations. So go in there and take a look. We'll have this in the slides that when we post it, you can get this. But just Google analytics and data Oracle user community on GitHub, and you'll find it. There are many other different resources and assets that are out there. Sudesh and Devani and I have done a few of these that are out there. This one I think is another version of the wine one. We've had some other ones we've done on, I don't know, predicting employee attrition with Garrett Cameron and some other different people. So there's a lot of good stuff out there. And with that, I'll close. Thank you, my colleagues for helping do this and deliver such a good job. Thank you everyone for tuning in and watching this webinar. And with that, thank you and good day to everyone.